Cambridge Assessment Admission Testing, 6th Term Examination Paper Step 2019 Paper 1 Mathematics 1 Code number 9465 Section A. The link to the question paper is in the description below. Hi, I am Babak. In this video, I am going to solve and discuss the third problem of this sample paper. Let me read the question for you first. By first multiplying the numerator and the denominator of the integrand by 1 minus sine x, evaluate the integral of 1 over 1 plus sine of x, where x goes from 0 to pi over 4. Okay, so I would say we denote this integral by I. Integral from 0 to pi over 4, we have 1 plus sine x dx. Okay, to calculate I, as the problem mentions, we multiply the numerator and the denominator by 1 minus sine x, which is the conjugate of the denominator. So in other words, I can write this and multiply the fraction by 1 minus sine x and divide it by the same expression 1 minus sine x dx. But if I multiply the numerators, it becomes 1 minus sine x. If I multiply the denominators, these two expressions make a conjugate pattern, so I multiply them using the conjugate pattern, and the answer is 1 to the 2 minus sine squared x. But 1 minus sine squared x, which appears here, is just cosine to the power of 2x. So then I can write the integral from 0 to pi over 4, 1 minus sine x divided by cosine to the power of 2x, and then I have dx. Now I can split this integral, this fraction, into two fractions by writing 1 over cosine squared and sine x over cosine squared x dx. X goes from 0 to pi over 4. And then I can write it as 0 pi over 4 of the first function, the integral of the first function, minus the integral of the second function. Of course, for the second function, the integral of the second function can also be calculated using the substitution method. But if you remember some formulas from the derivatives of trigonometric functions, we can do it a little bit simpler. Okay, here I can write sine x over cosine x and then multiply it by 1 over cosine x dx. It goes from 0 to pi over 4. But then this expression is tangent of x, and this is nothing except secant of x. Okay, and then if you remember from your studies, the primitive function, a primitive function for secant times tangent is secant itself, because the derivative of secant is secant times tangent. So let me write it down here for you. The derivative of secant of x is just secant of x multiplied by tangent of x. Yes. So it means that the first, and by the way, the primitive function for 1 over cosine squared is tangent. Why? Because the derivative of tangent is 1 over cosine squared. Okay, so by recalling you about these formulas, the first integral can be written as just tangent of x, which goes from 0 to pi over 4. What I have written here is the answer to the first integral, okay? And then I would write minus secant of x from 0 to pi over 4. But then this becomes tangent of pi over 4 minus tangent of 0 minus secant of pi over 4 minus secant of 0. Yes? And then if we continue, tangent of pi over 4 is 1, tangent of 0 is 0, secant of pi over 4 is 1 over cosine of pi over 4, which becomes 1 over square root of 2, and secant of 0 is 1 over cosine of 0, which is 1 over 1. And then what you get from the first pair of brackets is just 1, and the second one is square root of 2 minus 1. And if you open the brackets, the answer becomes 2 square root of 2 minus square root of 2. Okay, let us see how many. Okay, we can still probably start the second one here. So the second integral is the integral of 1 over 1 plus secant of x when x goes from pi over 4 to pi over 3. Okay, I will more or less use the same strategy. I multiply the numerator and the denominator by the conjugate of the denominator. Okay, so let us first give this integral a name. So let j be the integral that I am going to calculate. It is from pi over 4 to pi over 3, and then I have dx divided by secant of x plus 1. Okay, of course you see in the question it has been mentioned 1 over 1 plus secant of x. Instead of 1 plus secant, I have written secant plus 1, which doesn't matter, yes? And now I multiply the numerator and the denominator by the conjugate of the denominator. So therefore, j is equal to integral from pi over 4 to pi over 3, 1 over secant of x plus 1 multiplied by secant of x minus 1, secant of x minus 1 dx. So the numerator becomes integral from pi over 4 to pi secant of x minus 1, and in the denominator, using the conjugate rule again, this expression multiplied by that expression forms the conjugate pattern, so it becomes secant to the 2x minus 1. But I think probably you might remember that secant to the power of 2 minus x is 1 over cosine to the 2x minus 1, which can be written as 1 minus cosine 2x divided by cosine 2x after taking the common denominator, and the numerator now becomes sine squared x divided by cosine squared x. But this is nothing except tangent squared x. So this is just a quick recall of what is the formula for secant squared minus 1. So then I can continue here. I will continue this using this formula, and I can write it that it's equal to integral from pi over 4 to pi over 3 secant of x minus secant of x minus 1 divided by tangent square x dx. Yes, I forgot to write dx there. Okay. To solve this, I would prefer to multiply the numerator and the denominator by cosine squared x. So this becomes integral of pi over 4, pi over 3. I multiply the numerator and the denominator by cosine squared x. Yes. Now, here I multiply cosine squared inside, but secant is 1 over cosine, so one of the cosines coming from here and 1 over cosine coming from here will cancel each other. So this becomes integral from pi over 4 to pi over 3. It becomes cosine x minus cosine to the power of 2x. And the denominator, here I have tangent to the power of 2, which is sine squared divided by cosine squared, and then this cosine squared and this cosine squared are cancelled, and what is left is just sine squared. Yes? Okay, now let me just take this one with me to the next page. I'm supposed to continue calculating this. Okay. So what I do is I decompose this into two pieces. So this becomes the integral from pi over 4 to pi over 3 cosine x divided by sine to the 2x minus cosine to the 2x divided by sine to the 2x. And then I will have dx. Of course, here you can write it in this form, pi over 4, pi over 3. You decompose your integral into two pieces, but the first piece can be written as cosine over sine, cosine x over sine x, and then you have still an extra sine x left, which I write it in that form. And the next one, cosine squared divided by sine squared is cotangent, so it becomes the integral from pi over 4 to pi over 3 cotangent to the power of 2x dx. But the good point is that now you can write the first one. This bit is cosecant and this bit is cotangent, so this becomes integral of pi over 4 to pi over 3 cosecant of x cotangent of x dx minus this integral. I would write it as integral from pi over 4 to pi over 3. I would write it as 1 plus cotangent squared minus 1 dx. So I add 1 unit and I subtract 1 unit. The reason that I did this, because this is a famous combination. A primitive function for 1 plus cotangent square is negative cotangent of x. Okay? And then, so let me remind you of the formulas if you have forgotten that. The derivative of cosecant x is negative cosecant x times cotangent of x, and then the derivative of cotangent of x is negative 1 plus cotangent of x. So these are the formulas that you need to know, and then I can just calculate it now in this form. The first part using this formula becomes minus cosecant of x calculated between pi over 4 to pi over 3, and then this negative sign here with this 1 plus x cotangent x squared, using this formula it becomes cotangent of x, so it becomes positive cotangent of x, and a primitive function for this minus 1 is minus x, but I have an extra minus sign here, so it becomes plus x. Yes, and this is also supposed to be calculated between pi over 4 and pi over 3. Okay, so the first one becomes negative cosecant of x of pi over 3 minus cosecant of pi over 4. Yes, and then I have plus cotangent of pi over 3 plus pi over 3 minus cotangent of pi over 4 plus pi over 4. Yes, Okay, so we can calculate these numbers now. Here, if you want to calculate this, let me write it on top. For example, here it becomes minus 1 over sine pi over 3 by definition of cosecant, but sine of pi over 3 is square root of 3 over 2, so then it becomes minus 2 over square root of 3. And then this one is positive, because minus minus is positive, 1 over sine of pi over 4, but sine of pi over 4 is 1 over a square root of 2, so it becomes a square root of 2. And then here cotangent of pi over 4 is just 1, cotangent of pi over 3 is 1 over a square root of 3. So using these things, I can calculate it and write it as minus 2 over square root of 3 plus square root of 2 plus 1 over square root of 3 plus pi over 3 minus 1 minus pi over 4. Yes, so this is the value that I get. So we cannot simplify it that much, but now look here and there. I can combine them and just write minus 1 over square root of 3, and I have a square root of 2 and minus 1 here. So I would write square root of 2 minus 1 and then minus 1 over square root of 3. And then I will have pi over 3 minus pi over 4. Taking the common denominator, I can write pi over 12. So this is the value for the J integral that I was looking for. Yes? Okay. Now we want to go and solve the third problem, so I would say that it would be better if we go to the next page. So let me call it K. We are supposed to calculate the K integral, which is integral from 0 to pi over 3, 1 over 1 plus sine x to the 2 dx. Okay, here I multiply the numerator and the denominator by the conjugate of the denominator with containing power 2. So what I'm saying is that we can write it as this integral 1 over 1 plus sine x to the power of 2. You multiply it by 1 minus sine x to the power of 2 and then divide by the same thing. So the numerator becomes the integral of 1 minus sine x to the 2. The denominator becomes 1 minus sine squared x and then to the power of 2. Yes? So because this one inside and that one are conjugate, so they will give me this, and of course I have a power 2 here and there. But 1 minus sine squared is cosine to the 2, and I have an extra 2, it becomes cosine to the 4, yes? So if I want to repeat it, it becomes the integral from 0 to pi over 3. And then of course I can expand the numerator by the quadratic rule. Yes. And the denominator becomes cosine to the 4x, and I have dx here. Yes. Now what can I do is again start decomposing the integral, this fraction, into different pieces. Yes. So what can I do is this. This becomes integral from 0 to pi over 4, to pi over 3, 1 over cosine to the power of 4x, and then I will have minus 2 sine x divided by cosine to the power of 4x, and then I will have plus sine squared x divided by cosine to the power of 4x dx. Yes, of course you might solve these parts in different ways. Let me choose one way that I prefer to do that here. I would prefer to write everything in terms of secant and tangent. Yes, so I would write the first integral. It becomes the integral from 0 to pi over 3 secant to the 4x dx. So this is nothing except secant to the 4, sorry. This is not 2, this is secant to the 4. Yes. And then the next one, I can write it in this form. I can write it as minus 2 integral. Let me keep it in that way. It becomes sine x divided by cosine to the power of 4x dx. X goes from 0 to pi over 3. And then the next one becomes plus integral from 0 to pi over 3. Here I have sine squared divided by cosine 4. But I borrow two of these cosines and give it to this sine squared. Sine squared divided by cosine squared becomes tangent squared. And then I will be left with 1 over cosine squared. But 1 over cosine squared is secant. So what I'm trying to say is you can write this expression in this form. Sine squared divided by cosine to the 2 multiplied by 1 over cosine to the 2. Yes, but the first bit is tangent squared. Yes, this first bit is tangent squared and this is just secant squared. So then this becomes secant to the 2x dx. Now I have to calculate three integrals. So let me call this one k1, let me call this one k2, and finally let me call this one k3. Okay, first let us concentrate to calculate k1. How should we calculate k1? Okay, might be there are different ways to do that, but one way to do this, I can just do it like this. I will write secant to the 4 as secant to the 2x, secant to the 2x dx. So instead of secant to the 4, I decomposed it into this product. And then what can I do is to continue like that. Instead of this secant to the 2, the first one, I can write 1 plus tangent to the 2, yes, and then multiplied by secant to the 2x dx from 0 to pi over 3. Okay, now I can decompose this into two bits. It becomes the integral of the secant to the 2. If I multiply this secant here and here, then decompose the integral, it becomes this plus integral of tangent to the 2x secant to the 2x dx from 0 to pi over 3. Okay, but this integral is very easy. The primitive function of secant squared is just tangent x, and if you take this one u in your head, then this one is du. So this is u squared du. Okay, so if I want to solve it, let me do it like that. Then the first integral becomes tangent of x from 0 to pi over 3, but the second one is 1/3 of tangent to the 3x from 0 to pi over 3. Yes? And then this becomes tangent pi over 3 minus tangent of 0 plus 1/3 of tangent to the power of 3 pi over 3 minus tangent to the 3 of 0. But tangent pi over 3 is the square root of 3 minus 0 plus 1/3 3 square root of 3 minus 0. So then this becomes simply 2 square root of 3. Yes, so this means that k1 is 2 square root of 3. Okay, now let us go to calculating k2. Okay, so let me copy this here to put it in front of our eyes, paste it here. So this is what we call k2. Yes, this is k2, and we are supposed to calculate k2. Here, for example, I can take cosine x to be t, then minus sine x dx becomes dt. So this means that sine x dx is negative dt. And then, of course, this goes from 0, yes? So x goes from 0 to pi over 3. This implies that t goes from cosine of 0 to cosine of pi over 3, which means t goes from 1 to 1/2. Yes, so k2 becomes integral from 1 to 1/2. Instead of sine x dx, I can simply put minus dt, and instead of cosine to the power of 4, I can put t4. Yes, so then it becomes minus 1 over t4 dt, which can be written as integral from 1 to 1 over 2 minus t to the power of minus 4 dt. And then it becomes minus t to the power of minus 3 divided by minus 3 from 1 to 2, from 1 to 1 over 2. Yes, so then this is equal to 1 over 3 t to the 3 from 1 to 1 over 2. So if I put 1 over 2 here, it becomes 8 over 3 minus 1 over 3, and that is 7 over 3. So what I get is that the k2 is 7 over 3. Yes? Now, the last one is calculating k3. So let me take this one with me to the right hand side. So this is my k3. Yes? I will go to the next page, copy it, paste it here. So I want to calculate k3. And if you don't mind, let me clean this one and then write k3 here. I'm supposed to calculate k3, and that is more or less the same thing. You see, if I take this one u, if you haven't learned the previous one, you can also listen here. I can take tangent of x to be t. Then if I take the derivative of tangent, it becomes secant to the power of 2x dx. It becomes dt. And when x goes from 0 to pi over 2, this implies that t goes from tangent of 0 to tangent of pi over 3, which is 0 and square root of 3. So the k3 integral becomes integral from 0 to square root of 3, and then instead of tangent I put t, so it becomes t squared. And then the next part, secant squared dx, is just simply dt. And then it becomes 1/3 t to the power of 3 from 0 to square root of 3. So then it becomes 3 square root of 3 minus 0, which is square root of 3. So k3 is square root of 3. Yes. Now let us go back and see. If you look here, the integral k that I am looking for is k1 minus 2 times k2 plus k3. Yes, so what is k1? K1 is 2 square root of 3, and k2 is 7 over 3, but I have to multiply it by a negative 2, and then I have to add k3 to that. So 2 square root of 3 minus 14 over 3 2 square root of 3 minus 14 over 3, and then I have an extra square root of 3 here. So this is k1 minus 2k2 plus k3. This is supposed to be k. So this means that this is equal to 3 square root of 3 minus 14 over 3.